All right, so hello everyone. Welcome to an exciting talk. So today we'll be discussing about this talk, which is when rivers speak, analyzing massive water quality data set using SSH in Positron. So Rodriguez is a QA engineer at Posite. So stay keen and follow this exciting talk. Thank you.
Thank you very much.
Yeah.
And yeah, my talk today is when rivers speak, analyzing massive water quality data sets using Remote SSH in Positron. My name is Rodrigo. A little bit about myself, just to start with. I'm a QA engineer at Posit, and I'm originally from Salvador, Brazil. That's my city, by the way. But I'm based in Pittsburgh. My background is actually in chemistry, so it's very exciting actually to be at PyData Boston with the Python community because then I can get to learn a lot from the different talks and so on from everyone. And my main interests lie at the intersection of statistics, data, and society, specifically with how to use data and statistics to understand and improve the world. That's the overarching theme of many of my talks, and that's related to what I will be presenting today. Throughout the talk, if anyone has any questions, please feel free to interrupt. I really don't mind. So, yeah. So just an overview of the presentation, I'll start by talking about rivers as storytellers of human history. Then I'll dive more into the US Geological Survey sensor network. And then we'll talk more about the technical aspects of how to take advantage of all those massive pieces of data that are available through APIs. And then we'll talk more about remote SSH in Positron as a potential solution to enable capturing and making sense of all of this data. And then in conclusion, I'll just wrap up with how data science can be a tool for a better world. So beginning with rivers as storytellers, that's something that I became very interested, as a chemist, who is also interested in the statistics part of things. So this is a map of the US with all rivers that someone used open source data from the National Hydrography dataset in order to capture all of this. And in terms of rivers, what really makes me very fascinated about them is their ability to record several dimensions of human history, from migration patterns to industrialization, ecological resilience, inequality, neglect, and environmental deregulation or regulation, and so on. So just as an example, that's a historical map of the Delaware River showcasing the route that George Washington's troops went through. So that idea of rivers as storytellers of societies and of human history has always interested me. And that's part of the reason why I decided to talk about this today. And more particularly, along with that theme of rivers as storytellers, I was always fascinated by the amount of data that's produced, especially here in the United States, from these rivers. I live in Pittsburgh, and Pittsburgh has essentially the beginning of the Ohio River. There are two rivers, the Allegheny and the Monongahela River, that get together, forming the Ohio River. And the Ohio River has actually been used for a lot of mathematical modeling in terms of pollution and patterns of rivers, just because of the pollution that goes into it, unfortunately. So that's what I was interested as well about the idea of capturing that data from US Geological Survey in order to try to understand patterns of those rivers. And in terms of the size of that network, the United States has one of the largest environmental monitoring systems in the world, with over 2.3 million sites spread all over the country. And many of those sites are capturing data every 15 minutes. The station at the beginning of the Ohio River, for example, it captures a bunch of water quality parameters every 15 minutes, and there's an API streaming that data as we speak, leading to hundreds of millions of measurements, as well as several years of data. Some of the more recent data is more complete. However, even in the past, there has been some data being streamed from those stations. Which leads to two questions. Why should we care about river data? As well as how can we listen to these massive amounts of data that rivers have been sharing? And to answer the first question, I think water quality data reveals a lot of things that are of societal concern, including shifts in regulation, political priorities, economic development, environmental justice, and climate transformations, in a way that data is not just numbers, but the social history that encodes a lot of aspects of our societies. So that's why I became more and more interested in that. And in terms, how can we listen to the data that rivers are sharing? That was that is a challenge because both in terms of computation as well as storage and so on, it's difficult to be able to capture the magnitude of that data and to be able to process it and analyze it and so on. So that's what made me really intrigued by that problem. Which leads to us talking about the technical overview of what we'll do today. So the first step was to fetch the national data and national site index. That national site index contains the number that's assigned for each of those sites that are spread all over the United States. And the reason why we have to be very strategic about how to fetch is because those numbers are together with a massive amount of data. And a lot of those APIs are quite old. So it's difficult to be able to process all of that and to have a correlation between each number and each site. And there's no very accessible way to see, here's a list of all numbers and all sites. You really have to make API calls and so on to the USGS Water Services API. And then we'll go through the async ingestion of 3 years of data. We are only doing 3 years because just 3 years is already massive. We could go to 30 years of data and see what happens. One caveat, though, is that some of the data for some stations only became available recently. So that's the tricky part. So there could be a high level of missiness in some stations and so on. So that's what the third topic is, like scaling to 30 years. And then followed by structuring the big data with Parquet or DuckDB. And then finally, interpreting environmental time series as a sociological and historical evidence. Any questions so far that anyone has? Yeah, go ahead.
Where does this data live? Do you need to continuously record it, or is it there's some government servers you need to find?
Yeah, so the question was where the data lives. So there's the USGS API, Water Services API that you can make calls to. And that data is being, in a lot of stations, it's being streamed every 15 minutes, for example. If anyone wants to explore more this data, just a heads up that I think in January 2026, a lot of the API endpoints are being deprecated. So, yeah. Which makes that whole idea of exploring those data sets extremely relevant and pressing in terms of time. And it's easy to assume that someone out there is doing it, and I hope so, but just in case, I've saved parts of the data set in my machine. So the first part about fetching the national site index, there's a large inventory of more than 1.7 million rows after processing. and then doing some cleaning, the duplication, and filtering of the stream sites, which results in the master table that helps with the downstream workflow. I can show this part later. I think that would be easier so that we don't have to switch between applications now. But the idea is to use those values from the national site indexes as parameters to make the API calls to the 4 different water quality parameters that I'm interested in. And those 4 different water quality parameters are listed here in this table: temperature, specific conductance, dissolved oxygen, and pH. And each of them I find interesting because they reveal patterns around pollution, industrial activity, weather, and so on. And all of this is very important for the wildlife that lives in the river and in the surrounding areas of the river as well. And for us as well, we are also part of nature. So that's actually important to monitor those parameters and so on. Just as a caveat though, there are a bunch of other parameters, and some of them are actually very important to prevent or to plan for flooding, for example. There are some rivers in the US where there's flooding in the surrounding regions from time to time. So they do have parameters related to the height of the river and so on. So in terms of temperature, that can stress, very high values can stress the aquatic life, very low values can slow the metabolism of the organisms living there. The specific conductance is typically correlated with clean or polluted water. Low values would indicate that typically that the water is clean. High values could indicate some pollution from industry and so on. Dissolved oxygen is one of the main ways also to quantify pollution, because if you have very low dissolved oxygen, it usually indicates dead zones and fish kills, whereas high dissolved oxygen usually indicates a healthy ecosystem. And finally, the pH can indicate possible contamination or mineral imbalance in the water, which can cause some stress to the species and so on. Yeah. So then, in terms of the ingestion of those 4 parameters, there are thousands of sites for each state. Some cities might have even multiple sites where data is being collected, and leading to millions of rows per ingestion batch. And by ingestion batch here, I mean that in the way I planned the ingestion, I decided to do it by state. And then using async requests and thread posts to speed up the process is also helpful, which leads to producing the state level Parquet partitions. And in the end, just 3 years of data, 4 parameters, leads to 1.8 gigabytes of Parquet data. If you do it in CSV instead, it's much larger. If you decide to collect the other parameters, it would also increase massively, along with expanding the year window would also lead to massive expansion. And I will show that data after in the Positron application. And then I was thinking, just as a planning for potential future exploration, what would be like to scale for 30 years of data if there was a feasible way to outgrow laptop's limitations. And the reason why I say that is because although many of us do have machines that can process a lot of data and can collect at scale and so on, sometimes if you have limitations in terms of equipment, in terms of computing capacity, even tasks that we are used to in terms of data collection and processing can be a challenge. And even for 3 years of data, collecting the data without, just with my machine, for example, it took about 70 minutes of running it continuously. And during that collection, there's always the ethical considerations behind it as well, of making sure that you are not stressing servers, especially from government infrastructure and so on. So all of this is very important to consider. And we have tens of millions of rows of sensor data if we were to go through 30 years, for example. And if we scale up more than 4 parameters, that would also lead to several more columns. And I think there was someone who spoke earlier today about how columns really constitute a challenge for data processing capabilities and so on. And besides memory limits, some people can also be limited by storage. And that's how Remote SSH can help overcome some of these gaps. Any questions up to this point? No? Okay, cool. So let's jump on to how Remote SSH can be a solution to some of these challenges. So I start by explaining how it works in a higher level view. So in terms of compute and storage, there are different types of providers that can like provide virtual machines and so on, so that we can remote into those virtual machines. If anyone, and in my talks, I always like to give ideas so that people can try it themselves for free. I usually don't like to, let me recommend this provider or that provider. There are a bunch out there that are giving free trials and credits and so on. So if you want to try Remote SSH with Positron and you need a VM or a provider, you can just look it up for the ones that have free credits available. Some of them have very generous free trials. So yeah, that can be a good option. And what Remote SSH in Positron provides is a local UI with the ability to do remote computing. And that's very helpful because you're able to take advantage of Positron's capabilities and the UI while outgrowing your computer's resources and so on. And what I find really good as well is to pair the expansion of computing capabilities with other good practices when it comes to large data sets, such as using Parquet files, for example, which are fully supported within the Data Explorer and so on, which I'll show later as well. And lastly, that can help with a scalable network throughput for async ingestion pipelines, which is what we have today. One caveat, though, is that, of course, there are when you are making API calls, there are limitations that are beyond your control, and you also don't want to stress external servers and so on. Yeah, so I already explained some of these reasons why to use Remote SSH in Positron in terms of offloading some of the heavy data collection and processing work to a remote server, keeping the laptop responsive, having the workflow that data scientists usually like within Positron, and doing the long-run ingestion jobs and so on. And I think now it's a good time to actually show some of the UI and how these different factors are factored into the Positron's Remote SSH. So with that, I put some screenshots of different areas of the application. The first one I would like to highlight here is that you can pre-configure specific hosts so that you can connect to the desired host. So once you click connect to host, there will be a list of your pre-configured hosts, and then you can just go ahead and connect to it. This is very helpful if you have multiple remote environments, because sometimes people, for example, might set up one VM, one box for light tasks and another one for very heavy tasks. And since you're paying by the hour, you don't want necessarily to be using like the wrong one for the wrong type of need that you have. So that's how you can connect to the host. Once you're connected, there is a very clear indication that you are connected in the lower left corner. And I think that's very helpful to preventing anyone, including myself, from getting lost, from not knowing which box you are at. And I did play around with like multiple boxes. And at some point, I had to rely on that indicator to know, oh, I'm still using that one. Let me swap to the next one, and so on. And then one other part that I find really helpful is the automated port forwarding, which means that you can have different types of applications and the hosts being forwarded to the specific ports. For me, that I'm not used to assigning the ports myself, that's just generally really helpful. So you can run, as usual, the Shine apps and so on within. You can still run the Shine app within Positron with the automated port forwarding, even when you are inside the box. And lastly, there's the kernel supervisor, which is useful for very long running sessions, which means that you can shut down Positron but still have the remote SSH running in the background. Yeah, so with that, I'm gonna show a little bit about how the data looks like for anyone who is curious. I did put on my GitHub as well. Okay, so let me show here.
What's your GitHub? Can you git remote v?
Yeah.
Console?
Let me put it here. Yeah, I think, wait, if I go back to the presentation, let me go back to, just a second. Yeah, here we go. Yes, so I put the repo here in my GitHub for everyone to see. Of course, I didn't put the data because, yeah, but the script that I use both to fetch all the sites as well as to capture the data for each state, the Parquet partitions, it's all there. Okay, cool. So I wanted to show here the, yeah, so that's the Parquet files for 3 years for each state. And one thing I would like to emphasize here is if I go on to, for example, Pennsylvania, like that's how the data looks like. And again, this is after collecting the sites, all the sites and numbers. We can see here that we have the site number, it's all the same. To collect that site number, as I showed before, first I run the fetch.py, and then I went ahead to I created this Parquet file with all sites. And then based on those numbers, I went on to each state. So if I go on here, for example, for Pennsylvania, let me just hide some. The activity bar and the primary sidebar. Okay, cool. I can show better. Let me zoom out. So we can see here that we have over 20 million rows, 8 columns. And one thing I really like about exploring data within Positron, specifically with that Data Explorer tool, is the ability to interact with your data and get to know it better. Because especially now with AI, it's very easy to fall into the trap of asking AI to do things and then it messing things up. Whereas once you are actually interacting with the data, you get to know it better and you can avoid some pitfalls. One example I would show here, for example, is if we go on to filter by parameter, so equal to, so I'm gonna put the pH parameter, okay, which is 00400. And then I can apply the filter. And you can see here that it's like quite fast. And so it's 11% of my rows were for that parameter. And then one thing I know, I had noticed it before already, but I just wanted to show, I find it interesting about the data. Everyone knows the range that pH is usually assigned to, like up to 14 and so on. If you go on sort ascending, for example, you can see that you have minus 99999. Does anyone know why that pH is so negative?
Just like no data.
Missing
Yeah, yeah, just missing data. They just assigned that value. So yeah, situations like this, if you're not in close contact with your data, that's the type of thing that AI can pick on and really hallucinate. And yeah. And then let's say if you were to get the average, for example, of all of these, it would be quite bad because there is a lot, like we can keep going. Like there's a lot of minus 9999 data. Like, I mean, we can even like filter it. So let's say for value is equal to, then apply the filter. So there are 11,600 rows of missing data.
Is that applied? Because I can still.
Filter to negative 999. As there's a filter.
Oh, there's a
now.
different negative? Because I still have it.
Filter to include. Yeah,
Oh, to include, filters to include, sorry.
Sorry.
Yeah. And then what I find cool as well, let's say if I want to share this view with someone so that the person can put it in a notebook or something, I can just convert to code to like SQL, pandas, or polars, and I can just send it to them. So yeah, so that type of exploration is something that I'm really interested in data science, both through notebooks and data exploration in general, in order to enable people to, when they use AI, they can also know what they are doing with their data and so on. So yeah, any questions up to this point?
This is the Data Explorer, Positron Data Explorer?
Yes, it's the Data Explorer within Positron. You don't need to install anything. It's already native. And it works with pandas, polars, data frames, like anything pretty much. Any other questions here? Yeah.
You mentioned, I think in the earlier talk on Positron, mentioned that it's like a fork of VS Code.
Yes.
Right, and VS Code already has like remote SSH. I use it all the time at work. How much did you have to kind of like modify when you're developing Positron? Like, is it kind of just basically a wrapper on the existing logic, or what changes did you guys have to make?
Okay.
If any?
So I joined. He was asking about the changes that we had to make to enable remote SSH in Positron. I joined Positron in April.
Okay.
So to be honest, I don't know all the details of the work that went behind it. One thing that I would mention though, that using remote SSH, and I will mention actually someone who did the implementation, and I'm happy to put you in touch with him. But one thing that I enjoy about remote SSH in Positron is the ability to use it within your usual workflow of data exploration. So you don't need to swap between different applications or different things or install extensions or any of that. It's just already there, native, and all batteries included, and so on. Yeah. Sorry, I don't know the
No worries at all.
very
No
specific
worries at all.
details. Any other questions? Okay, so moving back to the slides. Yeah. So in terms of the results of some exploration that I did for the 3-year data collection, the ones in asterisk are ones that the speeds of the runtime were estimated, actually. I actually didn't do them, but I tried to use a machine that performs about the same as my laptop as a baseline, as well as some stronger, like higher computing capabilities virtual machines. And I essentially did the same task and recorded how long it took for each of the remote hosts. And I could get up to this point of reducing from 71 minutes, that's how long it took in my laptop, to 33 minutes, so by half, essentially, the time. Here the costs, hourly cost, total cost per full run. Of course, usually you run into issues when you are doing it. Sometimes something might stop working and so on. So I wouldn't budget based on how long something would take to you expect something to run, but it's a good indicator essentially. And the reason why I also stopped here is because once you start getting to a certain point, it doesn't really matter that much anymore what your computing capabilities are, because you might get rate limited by the API and so on. And you don't want to stress the server or any of that. So it becomes less of a concern of your infrastructure that you're using, more of a concern of the external, the server infrastructure of the API provider. So, yeah, and then in terms of when I think of processing 30 years of data, for example, I don't know what the results would look like, but it's very likely that that difference between my laptop versus more powerful machines would be very stark. The machines that I was using was from AWS, but there are a lot of virtual machine providers that can be good for that type of exploration. And again, taking advantage of the free trials, I think that that can be a really good opportunity for anyone interested in outgrowing their laptop with Remote SSH. Any questions about this part? Yeah.
Not a question, but just a remark. Not that I'm affiliated with them, but there is a company called Hyperparam that actually also has an open source JavaScript library that you can directly feed like, Parquet files into your browser. They re-implemented some of the compression and things like that. So it's worthwhile to take a look at them.
What is the name?
It's called Hyperparam. I can,
Hyperparam.
yeah.
Okay, cool. And then, yeah, so just a few remarks to conclude the presentation. First, as shown here, Remote SSH in Positron can help with any projects related to mass scale data collection, storage, and processing. It's very useful to do so, because in this way, users or any data scientists or data enthusiasts can take advantage of very powerful remote machines while remaining within the data science-focused ID environment. And in general, I'm really excited about building data science and open source tools that can help us understand and improve the world in some way. So that's part of the reason why I'm really excited about Positron and IDE development in general. And just as in my presentations, I always like to thank people who helped me throughout the process. I'm not a remote SSH expert, but he's an expert in remote SSH. He's one of my coworkers, and he gave a talk at PositConf about outgrowing your laptop with Positron. And if anyone is interested and wants to know more details about remote SSH, you're welcome to check. It's on YouTube. And I would also like to thank the United States Geological Survey employees who have been doing a lot of heavy lifting to preserve the much needed resources that exist for those API endpoints and so on. And again, if you are interested, feel free to fork, to clone the repo, to try it out, to collect some data from their API. Because again, maybe next year some of the endpoints I used won't be available anymore. So maybe it's the last chance we have to do so, which makes it even more urgent and interesting. And with that, I want to thank everyone for listening. Let's keep in touch. Here are my contact information. And again, I'm really interested in tools and data science with a focus on a better world. So if anyone is interested in those type of topics and projects, please contact me. And if you have any issues with Positron or Remote SSH, also please feel free to reach out, and I'm happy to help. Yeah. So any other questions? Yeah. Yes.
Have you made any interesting observations from that data you collected? Maybe any visualizations or?
Yeah, so I had done a blog post in the past with some visualizations showing. What I noticed with temperature, for example, there is a lot of seasonality and so on, that's very expected. Two of the variables were correlated, which I found interesting as well. I can send it to you, the blog post after. I think that would be the most helpful. Yeah.
I had the same question. I was just wondering whether, what stories you maybe got out of that, the data and the exploring it, that kind of thing. So.
Is there something that got you into rivers? Like something in your life that happened that made you interested in this?
Oh, okay. So, yeah. So it's when I was in high school, I was studying some differential equation for modeling pollution. And that differential equation is the Streeter-Phelps equation. It's modeled after the Ohio River by pure coincidence. Years later, I moved to Pittsburgh, and I was like, oh, this is the Ohio River, the famous Ohio River. And no one knew about that, but I was always like, oh, the Streeter-Phelps equation was modeled after this river. So that's kind of what made me feel interested in that.
Thank you.
Cool. Thank you very much.